Yet another video on chaos and fractals. This was the one video that I could not find done by anyone else, and that is how Feigenbaum or the logistic map relates to the Mandelbrot. There are some videos on it, but not from the mathematical point of view, so I thought, let's do it myself. So here we go. So here we see the Mandelbrot. And if you analyze or research what's happened on the yellow line, the x-axis of the Mandelbrot, you will find that it relates to the logistic map from Feigenbaum, which is here upside down, and I think also flipped from left to right. There is a visualization of this. I put in the link here. I'm not sure if I could use it, so I just put in the link. But it's done. It's used this simulation by Veritasium, which I gave 5 stars for his video on this equation will change how you see the world. But what is the mathematics behind it? Okay. Well, I did find the solution somewhere on a Reddit forum, but I did not find the derivation. So I reverse engineered the derivation. Here we go. This is the logistic map. I am assuming that you've seen my video and you are familiar. Well, let's just rewrite it like this. And then put a minus sign everywhere. And then add half and subtract a half. And then shuffle one of the halves from right to left. And then add r over 4 minus r over 4. And then pull out 1 over r outside of brackets. And then multiply both of them with r. And then reshuffle stuff. And I color code it so you can see how it's being reshuffled. And then rewrite the red stuff in this way. And then, is this correct? Yeah, it's correct. Yeah, okay. And then write it like this. Still, I did not change anything, we added stuff, but we also subtracted it and we shuffled around, but this is still the Feigenbaum logistic map equation. Oh, I'm in the way. Tom, you're in the way. Move. Let's see. Yes, this is much better. Now you can see what was going on. Next. So this is what we've done so far. We've rewritten the logistic map equation in such a way. Now I'm going to introduce P, which is defined by this, and Pn defined by this, and Q by this. And then we can rewrite the Feigenbaum or the logistic map equation in this way. So in summary, we just rewritten Feigenbaum in a different way using a substitution of different variables P and Q. Now let's have a look at the Mandelbrot set. This is the equation. We can split it because it's in the complex plane, and we are only going to be on the x-axis of in the complex plane of the Mandelbrot set, which means that the y component of the c constant will be 0, which means that y will be 0 all the time, and if we put that back in the top equation, we get this one. So we want from the more generic equation to the confined equation, confined to the x-axis alone. Okay, so far so good. By saying, cy will be 0, we will start at 0, and y0 or not will be 0 as well all the time. So this is Feigenbaum, this is Mandelbrot, and now you can see the relationship that the x in Mandelbrot is related to the x in the logistic map or Feigenbaum equation. And I'm going too fast, and the c is related to the r, which is the growth rate in the logistic map. Maybe I can put myself back on the screen. Maybe yes, let's see. Yes, there I am. Very good. So this is the relationship. Again, repeat it. Shall we do an example? Well, let's say we pick R to be 3.2 in the logistic map. That will give us an x component of the complex C in the Mandelbrot set of minus 0.96. Forgive me if I use points and commas in a different way here in Europe. Then the Feigenbaum population, after some iterations will bounce back and forth between these two numbers, and the Mandelbrot relationship, will be the x and the y coordinates will be, well, the y will be 0, but the x coordinate will be bouncing between these two, and that's how they're related. So I took a slice out of the Mandelbrot set on the x-axis. And here you see it bouncing back and forth, and here you see how it will bounce up and down in the Feigenbaum set. This is it. Well, thank you for watching. Bye bye.